All right, there we go. Too hot there, Mahan. All right. Hello, everybody. Welcome back into the stream today. Hope you're having a wonderful day. I'm back teaching myself some programming, doing some practicing, doing some Leet code today. I think we're going to potentially get into my next project soon. It's time to start doing that again. And then, yeah, so we're going to start getting into that hopefully soon, which will be good. But let's go ahead and just go at it here. Come on, don't give me too hard one. Oh, ain't no way. Okay. Okay, length of longest subarray with at most k frequency. You're given an integer array of numbers and an integer k. The frequency of element x is the number of times it may occur in an array. An array is called good if the frequency of each element in the array is less than or equal to k. Return the length of the longest subarray. The longest subarray is 1, 2, 3, 1, 2, 3. Since there's values 1, 2, 3 occur at most 2 in the subarray. Note the subarrays 2, 3, 1, 2, 3, 1 and 3, 1, 2, 3, 1, 2 are also good. It can be shown that there are no good subarrays with length more than 6. Change the title back to your mom. All right, we'll do it. All right. So, I feel like we're going to have to use like a sliding window or something here. Oh, look at that guy. Your mom. All right, we're back. We're back. Hey, how's it going? How can I improve my problem-solving skills? Honestly, I'm still trying to do that myself, but from what I've been able to tell is just by, when you feel that feeling that you're struggling, that's the feeling that you want, because that's the feeling that you're going to grow from and learn from. If you walk away right as you get to that feeling and don't really push through, then you're not going to go as far. So I've sat here on some Leet code problems for an hour and a half, and some people say to give up early and just watch the solution. And yeah, you'll learn from that for sure. But I do think there's value in like the struggle, right, of just trying different possibilities over and over again, different angles, thinking about different angles, looking back on your mistakes. Like, it just kind of helps that problem-solving mindset. Okay, so for this problem, we are just iterating over an array. So we just need to have like so we'll have a count is going to be equal to a hash map, and then we're going to say, right, n is equal to the range of, the length of nums, and then we're going to say, I mean, let's just think here. So if we say like for I in range of n, right? If we go ahead and access a number, if we look on a number, we want to add it to the count map. So we're going to say count index of nums index of I will be equal to the will be equal to, sorry, the count.get nums index of I else 0 plus 1, right? So this will do that automatic adding to the number of counts here. So we'll get the number of count, right? So really quickly here, so we come across this. So we're going to evaluate, so like, let's say we're going to like evaluate the number frequency, right? So we get the current count, increase it by 1. Maybe it's not like a sliding window problem. Okay, let's just add it to the hash map, and then go until we get. So let's say let's count get the number here. So let's just say num frequency current num count, right? So we're going to get the current num count. We're going to say if cur num count is greater than or equal to or greater than k, then we're going to so let's go. We're gonna have a this is gonna be, let's make this counts. Let's make this frequencies freak off, freaky Mike. Okay, if current num count greater than k, then we're going to, and then let's set this current count equals to 0 here. We're going to reset the count to equal 1, right? Meaning that we're going to reset, this count goes back to 1. No, count goes to 0. No, so we're evaluating, we have to think about this. We're evaluating on the number. So we're going to, let's not get confused. I often do this where I need to keep the flow of the for loop going in the right direction here. So if we evaluate the number frequency, we're going to, so we come across a number. Let's get its current frequency, right? What it's currently. If it's currently greater than 1, then we'll reset the count back. And then reset frequency back to an empty map. And say else, right? So else, if it is a valid digit in our sequence, in our good subarray, then we're going to increase the count by 1. We're going to set frequency key of nums index of I will be equal to current plus 1, current num count plus 1, right? Okay. So we'll increase the count. I'm going to say max count is equal to 0. I'm going to say if, so increase the count if count greater than max count, right, then max count becomes the count. We reset. Okay, let's think about this. So we're going to go over a number. We're going to get its frequency. Okay? So we're going to pick up number 1 here, okay? We're going to put it into our map. Right? It's not in our, we don't have it, so we're going to put it in the map. We're going to get it. Sorry, we're going to get current frequency. So for this one, this current num count will be 0, which is, this will not evaluate to true in this condition because k is 2. So we'll go here. Okay, and then we'll say, yeah, that's fine, I guess. So then if I move forward, okay, now I'm on the 2, I add that in. This doesn't hit because 2 has, this is 0 for 2. We increase the count for 2, or that we found a value. So we're going to reset this to 1 because we're going to start on that digit. Okay. So if the count becomes, so this goes valid, this goes, 1, that's valid, valid, okay. Now 1 gets thrown into our map. We get a current num count of 2, which is, so if it's greater than or equal to k, then we set the count to 1, reset the frequency. Reset the frequency map. Right, we reset the frequency map. So if current num count is greater than or equal to k, we set count equal to 1, meaning that it is at 2, so it's already maxed out. We've come across another one. Okay, so we're going to start now on this digit, on this new 1, reset the frequency. Not to that, not so frequency is going to be equal to a dictionary with the nums index of I and with a value of 1. Oh, we're not returning anything. Oh, spelling error. Oh, come on. First try, let's go. Ah, dang. Oh. Oh, because you have multiple subarrays. Oh, shoot. We have to go back. So it is a sliding window. You have to keep track of the window size. Okay, so your window... Okay, so it is a sliding window with a map. Frequency then, basically. Okay, so... We're going to have... let's have I is 0. Right, so we need to have a sliding window here. So we need to, how can we set this up then? We need to have I be our opening of the window that moves forward as we open, and then a leading variable, j. Now with the sliding window problem, do you have a nested for loop then? No, you just reset j to I plus 1. And you continue to move j forward. Okay, so j will equal to I plus 1, right? So j will be, and then we'll go 1 less than here, right? So if we want to evaluate the frequency of the number, so we're going to get the current frequency of this number I that we're on. Well, I is our start, so we don't really care about that. We just want to add How's it going, Next Gen? What's going on, dude? Hey, Carlos. This one's this one here. Okay, so sliding window. Okay, so if we have an opening portion as I, and then j leads I by 1. So if we're going to evaluate the current value of I, okay? Okay, we are then going to say while let's do this. So we want to say, we need a j loop, so while nums index j of frequency while frequency dot get nums index of j, well, here we're getting it as 0. So it'll be set, so let's just say that we had before. While frequency nums index j is less than k, we're going to say this here. So we'll increase the count. So this is going to get, this is getting the I though. So we need to do this for J initially as well. Okay, while frequency of J count, I count. So maybe we should say this. No, because I wanted to access this every single time to evaluate. So we'll increase the count. If the count is greater than max count, then go forward. Else set so we need to set this here. So I'm just going to increase I right off the jump, and take this one, put this here. So it just auto writes I no matter what. I will be the start of the window. But I don't want J to no, I don't want J to reset back to I plus 1. Because I'm doing O of n squared. So how can I instead right? So the thing is well, if I move the window in, right, if I move the window in, then I need to know I need to decrement the frequency map of that removal and go forward. No, but then I could lose track, so I don't know because if I have a window, right, and I keep the size of J fixed, so then if I found a window but it went too far. So then I just move I forward. No, because I need to evaluate the window on the next portion. That's the thing. Right, so I have to evaluate a starting window place on every value. Okay? But I can't necessarily just okay, so let's say I fill up, I come across a value that fills up my allotted use. But let's say like the starting value of the window isn't on a value that is filling up. So by removing that, right, so the thing is if I have X, Y, Z here in my array, right? If I have my open here and my close here, let's say I have X here, okay? let's use the example they gave. 1, 1, 1, 3, right? So if I have my open window here and my closed here at the start, let's say like I keep going, okay, I've reached a point where my closed gets to here. This doesn't evaluate, and I don't want to put my open, I need my open to move to the next value here. Right? But so if my open moves to the next value, which is my I, and I keep my C here, this is a valid, right? So I move C here. Well, I guess it doesn't really matter though. My question is because if I move the open forward and the closed is here, this already had a length of 2. A valid length. This has now a valid length of 2. Now this is going to go through here, and now we're going to have a valid length of 3. So my open, my J will just stay where it's at. Okay, so let's go like this. Let's say J is going to be equal to I plus, or I. We're going to start the window on the same place. Right? And then we're going to say while nums index of J frequency key of nums index of J is less than K, which right now it's not in there. So we need to add it. So we're going to say while right off the jump, you have to add I to the frequency map, right? So we're going to say frequency key of nums index of I equals to frequency dot get nums index of I L0, right? So we'll get the current value and update that value immediately for I. You're opening, right? Okay. Well, you said it right away. No. I will move forward. Okay, let's just see. Okay, while the frequency index J is greater than K, less than K, we're gonna say max count plus, I'm gonna take this same statement here for J, right? We're gonna set the closing point as we move forward. So this is gonna error out though. So J is that, which J is equal to I at the moment. Binary. Okay, while frequency J. Oh, I'm losing it here. Hold on. Google referral. I probably fail that one. Okay, so come on, think, Mike. You can do this. So if we open the window on I right away, we open the window on I, we are going to continually, let's just say while true here, I guess, continually you get the frequency of J move J forward. Well, let's just say this, for J in range we don't want J to exit. So say while true, okay, we're going to, if frequency, if this of J, but J in this first case equals to I. So let's make this I plus 1 here at the start, I guess. So while true, we're going to get the frequency of J current J frequency. If current J frequency greater than or equal to greater than K, we're going to, if the frequency of J is greater than K, we're going to break out of this loop, leaving J where it's at. Okay, yeah, we're gonna break it right there. So else, if it's not greater than K, we're going to update the frequency of J. So this is current value that we're on. say J frequency. If the new value we're on breaks, update it. If the new value of it breaks, we're going to need to also go nums frequency nums index I less equal 1 and break frequency nums index of J equals to, we're going to update this to the J frequency, and then increase count, say if count greater than max count, then max count will become count. And we then say J plus equal 1. We'll say while J less than N, do this. Okay, so for I in the range of N minus 1, frequency of numbers index I. Okay, so this is going to pick up I, number 1 here. It's going to save 1 as the frequency key and then get 0 there and then add 1. So now 1 has a value of 1 in frequency. J is going to be equal to I plus 1, so J is going to be on here. We're going to get the frequency of J currently, so J then gets added into the frequency map. If the J frequency that we currently updated is greater than K, then we're going to reduce our opener we need to continually reduce the opener though until we find a valid right. So if this becomes valid, that means everything before it is valid. So what if you had like back-to-back ones here though, right? It would break on there. Say if it was 3, 1, 2, 3. This is 1, 1, 3, 1, 2, 3, and so it breaks there. You would need to move I forward until we would need to move I forward until it's a value that isn't what the one that broke us is, right? So if we found a value that broke us and we reduce the frequency of this, because we're going to move on from it, if we come across it, it's going to break it again. It's going to increase the frequency of it back and do it over again. And then it's going to say wait. Right range N minus 1, frequency nums index I equals to frequency dot get nums index I. Okay. So I move the window forward. Now I need to move the window forward though until I get to a valid starting point, right? Give it some nums and this one move forward. Probably is valid on. Okay, hold on. So we update the current frequency of the opener right off the jump. So then I need to say we're going to get the frequency of J because it is smaller than N. Interesting. Okay, so I need to open the array or open the window and then keep the window going, keep moving I forward. So maybe I'll say while I so let's do while frequency dot get nums I greater than K less than K. We're gonna update it. While J, if J frequency becomes, we're gonna now we need so what if I say just like while I is less than oh, my brain's not working right now. Okay, so I'm gonna look up sliding window. Oh. Freakies. Zero blah blah starting with I. Plus one. So you go evaluate current sum equals to that's not what I was looking for. Let's look up here and go, can you walk me through an example of a dynamic sliding window? You should find the length of the longest string without repeating characters. Grows and encounters unique characters. Make like this. Don't show me any code. Let's use words. string calls left, one that moves forward one letter at a time. To the right edge of the window. Keep track of what's inside the window, specifically all characters you've seen. Call this our scene set. Expand the window to include a. Okay, so let's initialize. Okay, start with two fingers, one at the beginning of the string, call this left edge of the window, and one that moves forward one letter at a time. Okay, so we have frequency. Okay, so we're now left is going to be equal to 0. Right is going to be equal to 1. Okay. For I in range of n, there. We're going to add j in every single time. J is equal to 0. Say, what is going on out there? It's like booms and cars and what is geez Louise. So we're going to access frequency nums index of j equals to frequency dot get nums index j else 0. Okay. We're going to update the frequency of the value we're on. Okay. If frequency, so I'm going to say this is j frequency. If the j frequency is greater than k, then we're going to do something here. Okay, else, and then we're just Okay, so you start with both fingers on the first letter A. You haven't seen anything yet, so you expand the window to include A. B is in the window. Okay, so now we're going to say frequency of j we'll say true. Get the frequency of J if frequency of J ever comes, we're going to break out of this. So we'll say frequency.get nums index of I here. Say and say L is equal to 0, R is equal to 0. While true, going to say if so frequency dot okay, 1 for this value. 0 plus 1. Let's look at this value. So let's say this is start the both the left and right points at the beginning of the array. Track how many times each number appears in the current window. So this is how much. Get this value 0. This is val. If the val is greater than k, then we're going to while nums index L while num index L num index of L is value frequency key is equal to while frequency while nums index L is equal to nums index of J, let's increase L by 1. So if the value of the current frequency of the digit is greater than the allowance, then we're going to increase the opening to move forward, and we're going to do that. So then we're going to do this check right? If num's index L is equal to num's index J, we're going to enter this while loop and increase L until it does not equal J. And then we're going to if you come across a breaker, so else, if the value is valid, then we're going to my brain is really not working right now. Oh my gosh, I can't think. I'm like losing all my train of thought, you guys. Okay, so if the value is greater than the k, the allowance, if it's not, then this is a valid value. We're going to increase the count of the length. We're going to say if the count happens to be greater than the max count, then max count will become equal to the count, right? And then we're going to increase J by 1. While J is less than N. So once J becomes less than N, we've reached the end of the array, and there's no point in shrinking the open forward from there because it's only getting smaller. So while J is less than N, we're going to get the current value of J. So let's just map this out. Let's not be lazy. So these are our digits on the one we got wrong. Here. Okay, 1 1 1 3. Okay, let's go back to our code. So what we're going to do here is we have an n equal to 4. Okay, so L is going to be here and R is going to be here, right? So on the first pass, L is here, R is here. Okay, we're going to get the frequency of R, right? Or not J. Let's say R. Hey, how's it going, Fernando? I study after work, usually around 7 p.m. PST. Today I was a little bit late though, so sorry about that. Okay, so we're gonna start here. We will enter in because R is less than N. Right, R equals to 0, L equals to 0 here. Okay, so we're going to step into here, we're going to get the frequency of this, which this is, so the value at this point in time is equal to 0, which is less than K, right? So this is not, we're going to enter this, we're going to increase count is equal to 1, right? So now we have max count also equal to 1. Saving the coda and the mitochondria. How's it going, Dr. Love? I like that name. Thanks for coming in. I appreciate you so much for joining me. Yeah, my name is Michael. I have a degree in human biology and a minor in chemistry. I've been teaching myself how to code for about a year now. I have some cool projects like spectrosim.com and chromoplot.com. You can access all my projects and my information at michaeldeming.com and also in my Discord down below for free. So everything is for free. Okay, and I stream every single day. Okay, so and then on the next pass, hey, thanks for the follow, Dr. Love. So on the next pass, L stays at 0, R becomes 1. Value in this case is equal to, value in this case is 1, right? We added 1 to it. So now value is 2, which is less than, which is not greater than k, right? So count goes up to 2. This becomes 2, and then this becomes 2. Okay, so now we move R to here, to index of 2. Okay, value becomes 3, which is greater than k. So this is the flag we're looking for, right? Right. So, right, this is the flag we're looking for. So that being said, we're going to hit this while loop. We're going to increase L by 1. While L, if, I'll take this one, I'll say while true, if nums L is equal to nums R, right, then we're going to continually increase L until this is done. If it isn't, we're going to break. Okay, so if the value is greater than, so now we're going to increase L each time. But what we're going to do is we're going to decrease it as we move L forward. No, so we want to move it forward no matter what, right? And then I guess we'll just have this be in our, like we had it before. While these two are equal, if they are, right, increase L. In other words, we're going to decrement the value of frequency at nums index of L less than or equal to 1, right? And then we're also going to do that every single time we move L forward here. Okay, so what are we doing? So we're starting L and R at the same place in our array at the start. Our R variable cannot go past the length of -1, right? But we want to, we don't want the window n minus, this would be n minus, potentially, I'm not sure, hold on. So, we're gonna get the value. think we start with on the window on 1. Or on this example here. We start on 1. The number appears less than 2 times, so it's valid. Expand the window. It's still valid, valid, still valid, 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 invalid. So we shrink the window to this size. This value does not equal to this value, so this won't happen. So then do we just count here? If the value is greater than k, we increase L. Oh, we get the... If it is... Let me break out of this. Let's try this. Oh. Wow. How's it going, Bizwine? Welcome, dude. Okay, so frequency nums greater than R will increase the left pointer. R. So R can't go. Wow. This is going to be L. And get the current value of L. Ugh. I want to see some stuff. Yeah, so I was right before. Okay, so the R has to be less than N, right? Because we can't, that's when we'll hit here. I just have to know what I want to know. Get the value of R. If the value of R is greater than there, then we're going to shrink the window by increasing L. invalid frequency. I'm tired, you guys. I'm kind of beat this stream. I'm pretty beat this stream, you guys. Okay, so we're really close, I feel like. I've honestly never done a sliding window before. It's our first time. I know it. I've known we were going to get to it sometime, and I've been delaying it, but it's been inevitable, and we got hit with it today. Okay, so our right pointer, our right side of our window cannot reach to n, right? It has to be less than n. We're going to obtain the current value of our right pointer. If the right pointer's value, or count, frequency count, is greater than k, it's invalid. So we're going to increase the L pointer by 1, and then remove it, and then decrement the frequency, right? If nums index L is equal to nums index of R, right, at this point in time, then we're going to enter a loop to continually move L forward same to while true. If numbers index L is equal to R, we're going to increase L by 1 and go frequency this here, right? And then continue, else break. Okay, that breaks out of this loop. Oh, we found that. We update the frequency, reduce the frequency. Count will increase. So we need to decrease the count. Okay, so let's go here. We have to decrease the count as we reduce the size of the window. So the window reduces by increasing the left side, and we reduce the count. asking the length. Interesting. Yeah, I just have my walkthrough here pretty much, where I just asked for some examples regarding just some pseudocode. Right, I just wanted to walk through in words. So I'm trying to get an example. I've never done a sliding window before, so I'm trying to learn it here. So we asked it to just use words. So I'm trying to just walk through the kind of pseudocode logic here to understand. Okay, then I even gave it my current solution, my current attempt, and so we have some notes here that I'm trying to improve upon to learn this, right? So start with both window edges. That's right at the beginning, just like we're doing. We're going to continually get the R frequency. So we're going to get the right-hand frequency, and we're going to continually increase the size of the window as long as the frequency is still valid. Okay, so we're going to get the frequency as long as it's still valid. So if value is less than k, then what we're going to do, this means it's a valid value, right? This is valid. So if it's less than k, we're going to increase R by 1, right? We're also going to set max count to be equal to R minus L plus 1. Yeah, I think so. Right? So R minus L plus 1. So now if we, okay, so now that sets the max. So now we don't even need to do this counting as we go. We can just detect a max count by taking the difference between the two pointers plus 1 for the 0 index. Okay, so then, because if it's 0 and 1, that'll be one value, but there's two values, one value at 0, one value at 1. So you need to add plus 1 to give 2 for max count, yeah. So if it's not valid, so then we're going to say, what, continue here? If it's not valid, we're going to shrink. So this is not valid. So we're going to shrink the window, right? So we want to shrink this window. So let's go ahead and say while true, if n, while true, let's reduce or increase L by 1. We're going to, oh, but we have to update the frequency, so this gets the value. So we're also going to update the frequency, right? So frequency index of nums at R will be equal to the value that we currently have. So we're going to shrink the window, we're going to say frequency nums index of L less equals 1. If frequency, or if nums index L is equal to nums index of R, then we're going to continue this loop, else we're going to break. So we're going to enter a loop to continually shrink the size of our window from the left pointer, right, until we meet a number that isn't the one that caused us to end or to be past our limit, right? No, because it'll already do this by moving forward in this loop, right? It'll continually, so we don't even need to do this. Okay, I got you. Because if we leave the right pointer where it is, L will evaluate to, it'll still be false. No, I don't want to though. Get the current frequency. Okay, so let's just get the current frequency. If we get it, we'll then set it +1. Else, if we don't get it, then we don't need to loop. We can just increase L. We can just increase L, right? Increase L forward. Reduce that out of the frequency map. No, we have to do this before. It's equal to val less than 1. Okay, so now this will get the right. If this is still currently invalid, Hey, what's going on, Python Knights? How's it going? We're just doing some Leet code problem here. We're trying to solve this sliding window problem. I've never done a sliding window before, so we're trying to learn it here. Okay, so we have the left and right pointers starting at the same time. Our right pointer can only move as far as it can in the array. We get the value of the right pointer. If that value, or the frequency of the value of the right pointer, is less than the tolerance, then we're going to set the frequency +1. We're going to increase the right pointer, and then update the max count of the two pointers difference +1 and continue the loop. If we come across a value that isn't, for example, this one right here, we're going to increase the left pointer to here, reduce the frequency count of this one, we're going to access the frequency of nums, the current one, minus the current value. So we'll say minus equals 1. we're going to increase the left hand, break. And we don't want to break out of this. So increase the left hand. We get the value of the right. Okay, so we do want to update it here then. Okay, we do want to update it here into the frequency map. Right? And then we're going to say if the frequency of num's index r is here, is less than k, then we're going to go into the frequency, increase it, increase r, increase the mouse count, and continue. This index still out of range. List index out of range on the nums index L here. How? List index out of range on this call here. So my nums index L is giving me an index error. So what index is it trying to access on num index L? Well, it should be 0 at first. So nums index L is 0. Nums index of 0. The frequency of nums index L reduces by 1. What? All right, let's keep going here. So we have 0. It's going out of range. Getting the current. That's the index of R. Thingamajig. Start with both windows, get the L at the beginning. For every element at R, do this. Add it to the frequency map. If the frequency exceeds case, shrink the window from the left. Keep moving from the frequency map until all values. Yeah, we got that part. Okay, we figured that out. Oh. So you always move R. R doesn't stay if you shrink? Move R forward. Shrink until it's satisfied. To move R from there. How's it going? Welcome, Indus. Okay, let's get some feedback on our current go here. So say no, don't show me any code. What kind of feedback? Okay, so you're doing a good job. Expand and shrink. Understand what makes a window valid. In this specific problem, a window is valid as long as no element appears more than k times. This means that k greater than or equal to k is invalid. Your core logic adds 1 again. Yes, I should. Yes, this is wrong. Adds that incorrectly. After checking if frequency nums index r is less than k. Two separate phases. Expand by moving r, shrinking only when constraint is violated. Your code tries to do both in the same block. Okay. Hey Spectre, how's it going, dude? Alright, let's keep going here. So it's annoying. Okay, so we start at the same place for both point left and right. We're not using this length anymore. And this is frequency. So if the frequency of this current right pointer is less than k, we're going to move r forward. Okay, let's just do this and say, how does this look for the valid part? You want to check if adding the element in the window keeps it valid. You want to check if adding this element to the window keeps it valid. Updated max count. We've already moved r forward by 1 just before this r is now pointing past the valid window. You check frequency is less than or equal to k. Right, we check the frequency. Then you move r plus equal 1. Sorry, I'm just reading chat. I'm sorry, I'm just working through these problems. I'm not really talking to the chat right now. I have it on max volume. It's just how it is. I mean, I can turn it up even more, but it starts to peak. Let me keep going here. No, I'm not using that. I'm not gonna make a list. This is supposed to be what it is. We're supposed to be using a hash map to be able to count these frequencies on key gets. So I don't think you're understanding the problem. So less than or equal to. So max count at this point in time would be R minus L. So we've increased R by 1. Oh, we've already increased, so that's why. So then it would stay. So R would go to 1. But we've increased R, so that is valid. So let me go here. I want to keep this as, I liked having that, so then we'll put that there. Now that'll work, as I had it there. Okay, so continue now on a not valid, right? So on a not valid, we need to shrink the size of the window. So L, while true, no. L will increase by 1. Right? Also, we increase the left pointer by 1. So we shrink the window, but we want to do that as many times. So let me say, am I right for the not valid part that I need to loop until L and R are not You've added numbers to R, now it's going to greater than. So you need to shrink the window from the left until the condition is valid again. You don't need to loop until R. You need to loop while the frequency of numbers index of R is greater than K, because that's only the reason the window is valid. While the frequency of the numbers I just added. So I just added a number of frequency, right? While frequency nums index of R greater than K, we're going to continually increase L by 1. No, we're going to decrease the frequency of this. So frequency nums index of L less than equal to 1. L plus equal 1. Well, the frequency is greater than K. We're reduce the frequency of the left-hand value So right now it's invalid, right? We're in an invalid state, which is hitting in this while loop. So we're going to move, we want to move the left-hand pointer forward one time. Frequency number is index of L minus equal 1. Oh, jeez. Oh, all bots back. Here we go. Yeah, we're using key value pairs right here, my guy. You gotta read the code, my guy. We're setting key value pairs right away using the get method on this frequency dictionary of the keys numbers index R. So you're keeping a frequency counter using a hash, or using a map, basically, right? And then if your frequency ever becomes invalid, you enter an invalid state, and you have to shrink your window until it becomes valid. So else, while the frequency of the index R is greater than K, we're going to reduce that occurrence of L and then increase L to the next value. So we're going to reduce the occurrence here. So we hit this one, it increases the occurrence. We're going to reduce the occurrence on this one and move L forward. Now this loop does not happen. And then so then we say return max count here. Is that all we need? Still here. So we need to do the R, because that will still resemble that same value of L technically, because infinite loop. Dang it. R increases until it. So this was pretty. Wow. Well. So I'm going to take my not valid portion. How close am I for the not valid part? Why are you showing me code? When the frequency of the number you're when you're shrinking the window, you're assuming that you should decrease the count of the number you just added. The one on the right side of the window. But here's the catch: when you move the left edge of the window forward, the number you're removing in the window. Yeah, I did that. I did that, but I get index error for the nums frequency nums index of L. You're getting an error and trying to subtract the count from the number of the edge of the window. That's because the number might not exist in your frequency map, or edge count might already be 0. Before I subtract the number count, I need to ensure that it was actually added to the window in the first place. Why wouldn't it be there though? Like, why wouldn't it be there if our pointer already added it to the frequency? If the right pointer added a number to the frequency map, then that number should be in the map when the left pointer tries to remove it. That's true, but only if the left and right pointers are aligned correctly and nothing was skipped or miscounted. Why are you still getting an error? Let's explore a few real-world causes. You might be entering the shrink window loop even when the condition doesn't demand it. Always check whether the number at L has a count greater than 0 before subtracting it, or remove items from the frequency map that you know are still contributing to the violation. Optionally use a default value, like the dict get, if you're unsure. Even though the right pointer adds a number, you're either over shrinking and hitting a number that's already removed. Hey, big task, how's it going? So I'm going to say, okay, then let's just say, given my current attempt, where am I going wrong? You're clearly building the frequency map. Incorrect max window size formula. You don't need to check for valid and then continue. So R will go forward. So then let's call this 1 plus R. A valid number that you found. So then if you say, you don't need to check for valid and then continue once you update the max count. Is that not what I had? L? Okay, so I'm on 0, 0. I evaluate that number as true, valid. I increase R. So R is 1. L is 0. 1 minus 0 is 1. There's one letter number in there, so that's max count. What am I getting this index error? Wackathon, I don't know. I still, we haven't come up with a real idea yet. And I'm not getting a lot of participation in the Discord about it, so I'm not really that inclined to do it if people aren't really wanting to, you know, provide suggestions and stuff regarding what we should do. So I'm just going to continue building projects solo, really, if people don't want to build things together. It's kind of a lot of work to just do by myself, so I mean, I'm just gonna continue doing my thing then if other people don't really want to participate either. So I don't know. I put some suggestions and stuff in the chat, and no one really responded and whatnot. So I don't know. I'm still not following really. Like I know what's going on, but right now, if you're else. So in both cases, you have to advance R. Really? Why do you have to advance the end? I don't get it. Keep adding ones. I'm done, dude. I'm burnt. I don't think I'm gonna call it here. I got 6 more minutes till 10 o'clock. Can't even solve one leak code problem tonight. Get out of here. These ads are so trash. I'm not gonna watch these.
Okay, so we noticed that. Now, look at our first window. We have 1, 2, 3.
Hey guys, Greg here. Today I want to talk about a very popular algorithm, size 3. If we expand the window, so R is going to expand the window. Here, our window would be A and B together. If we then contracted the window, it gets smaller. Notice that it's kind of sliding over in general to the right. It's both N because we're always moving these things over here, so that'll be a linear solution. This would, again, our window would just be here. We could, for example, slide R a few times over. Our window would be between these characters. More equivalently, our substring would be BCAB. And again, we could kind of contract this over. Our substring would then go to CAB. So let's cover exactly how we're going to do this for this problem. Now, we know we don't want duplicate characters, so we definitely want a set. If your mind went to like a hash map or a hash set, that's great. If not, that's also okay. But this thing is a constant lookup where we can immediately see, as long as we have all the stuff in here of the characters we've used, we can do a constant lookup and say, in O of one time, we can say, have we used an A before? I'm saying our window is valid. We want to. The way, how do we actually calculate the length? Well, we could calculate the length of our set, but in general, R, aka this character, if S at R is in the set, yes, it actually is. Okay, that means that the current substring we're looking at is invalid. It's invalid, so we are not going to update this because what we have here is actually a failure. You want to move L over to start to make the window valid. We want it to be valid at all times. When it's valid, we move over R. When it's invalid, we move over L. Now, if you were just to blindly move L over here, well, that's not going to ever fix the problem because you'd again ask, hey, is this character in the set? Well, yes, it is in the set, and it's always going to be in the set because you didn't remove it over here. So before we move L over, you have to remove S at L, aka this character, from the set. So the window is in.
That's what I thought. That's what I thought. So we remove from the set and we move L over. I'm gonna do it. Let's go to here. 2985. Probably gotta debug this thing. Okay, let's go here. Let's figure out why I'm getting this index error. Okay, so step into this function. 1 and 1. 1 and 1, 2, 3. Valid. 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 Okay, this becomes invalid now. Right? 1 has an invalid. Okay. I reduce it. So that did it appropriately. So now it goes down again. Goes down again. Now we're back. Too many ones again. Oh, I'm stuck in this loop. Here. Okay, so then we need to L increases. And then we got sent back here, but R never increased on this pass. So then no matter what, if we increase R, there's 1, 2, max frequency is 4, 5, we should get one more, 6. Okay, now we should get invalid here. Okay. Reduces L. Goes to 1 now. R moves forward. 6. Okay, so now if we come here and add +1 here and then move the R value here. Boom! Power of the debugger, baby. Power of the debugger. No! Oh, no! Oh, no! So close. So close. Hey, Anand, how's it going? What's going on, dude? Okay, so failed this test case. So let me take this array. Make this 1. Let's see. 1 and 1. Frequency 1, 2. 4. Max count is 3. Oh. Okay, so it hit the max, it hit this reassignment on another valid. we'll have to say if to this here. Oh. So if you found only on valid, is there a way we can just do that without adding logically checking? Not I don't know. What to see. Okay, we passed. So is there any way to update the max count automatically somewhere on here without doing a conditional check? If this is valid, let's update. Where can we stick this? Where can we stick this so we don't have to conditionally check? So you get the frequency. If it's valid, you update the max count for that. I don't necessarily need to. So he sets it up. I want to see here. Is there a way we can set up the automatically? Instead of checking if, just always assign the maximum of the two values. At every valid window step, update maximum count to be the maximum effective of self. Okay, so I guess we'll just say window size is equal to this. And we'll set max count equal to the max of window size or max count. But this seems kind of silly. Is there a way? I want to see, is there like some other solutions I can look at here? Oh, so they did the same thing here. Yeah, okay. Cool. these ones. Let's say 290. O of, so what is the running time? O of n? Use frequency, okay. So you move it forward and just, I feel like it's slower though than O of n. Does it not take time to drag? Does it not take time to drag the L pointer forward on invalid? Let's clarify the dragging the L pointer forward. Even though the L pointer forward moves inside a while loop, it still only moves forward, and it moves at most n times total over the course of the algorithm. Every iteration over of the outer loop increments r by 1, so r moves forward n total times. Inside the loop, L might move multiple times for 1r, but no element is ever visited more than once, by L more than once. So in total, r moves 0 to n minus 1 times. L also moves 0 to at most n minus 1 times to n times. Together, that's 2n operations, which is still O of n. Imagine you're pulling a rope at the window and both hands can only move forward. You might move your left hand shrink quickly in some steps and the other hand expand slowly overall. Interesting. No, I've never done code forces. Hey, Alexis, how's it going? On not valid, just remove first of the window. So the thing is you have to continually reduce your window size from the left, the start of the window, until your logic is back in play. Because what if you have like what if 1 is what the number that you hit that makes your logic invalidate, but then you have a bunch of 1s left in your pointer, right? Like 1 1 1 1 1. Well, you have to go until all of those are cleared until you get 1 less, 1. So it would shift 1 by 1. If all of the values are 1, you can only have a set number of 1s in there. But yeah, you have to drag it, right? Cool. All right, so that we got a lot more familiarity with the sliding window. I feel a lot better about that. Now I know I did struggle a little bit through the problem, but that struggle did help me, understand this a lot better. I've been putting off trying to learn sliding windows for a while now because I knew it was going to be kind of a little bit of a struggle. But now that I've kind of gone through it, I understand that okay, you have a left and right pointer that all start at the same point. Once you move the right pointer forward until your logic is invalidated, and once it's invalidated, you move your left pointer on an invalidated, but your right pointer will always move forward on every pass, right? So you can have whatever your logic is, doesn't really matter. The sliding window itself has that. The 2 pointers start at the same place. The right moves forward no matter what, and once you become invalid, the left will move forward with the right until you have a valid sequence of that length, right? Because you found the maximum length, so there's no point in shrinking the window and starting again. So if you found the maximum length already, you just keep that maximum length, right, by moving L and R forward in this case, right here, until you reach a valid point to where you can then keep your window growing. Okay, so once you reach a valid window size, it will then, so your window will start at nothing. It will then, let's see if I can write this out. I know it's gonna be kind of hard. Pause. So your window will start at nothing, right? You have L and R starts at nothing. R moves forward until it gets to a point somewhere in the future where you have some sort of spacing between here, right? And then this is valid. Let's say that this becomes invalid now. This size will move together until we reach a point where it's valid, and then R will start going off by itself again. So it starts off, R goes independently. Once it becomes invalid, they both move together. Once R becomes valid, once it becomes valid again, the R then goes independently. That makes a lot more sense. Yes, yes, yes. One question: when you were in the beginning to learn code, what was the first thing that you were having trouble with? Um, Pretty much, honestly, I honestly, when I first started, I had trouble understanding like as basic as print statements because I didn't know anything about programming at all. I didn't even know like when David Malin in CS50P was explaining like the print function and I didn't even know like what a function or what it was or what even displaying text to the screen did via some sort of programmatic call. Like I didn't put that together. So I struggled through those as well, and so you know, it took me like even like the backslash n like in the print statement backslash n new line. I was like when he said that I was like, what does backslash escape characters like? What like it really just did not make sense to me. And so, but I watched it over and over again. So it's just even simple things like that trip me up. So don't feel like discouraged if the really basic stuff is tripping you up because it's completely new things that you've never really had to deal with before. At least I did at that time. So even those simple statements of like little parameters in the print statement, knowing what escape characters when he said because he mentions the escape character backslash n in print in the first lecture week 0. And I remember I had to go back and watch that chunk again because I was like, I don't know what any of this means. Like, what is this? So I get like, yes, print puts something on the screen, but backslash n comma, you have a quotes a string with a comma. You can concat. It was just like it was a lot, right? At first, even just a simple, but just by slowly building like just Legos together of little pieces, of tidbits of information, one on top of the other, it really helped. And then I kind of felt the same amount of like struggle, especially it ramped up when I got to object oriented programming in classes. Now when I got to classes, I remember sitting through that lecture being like, this is going to be the hardest thing I've ever done. Like I was like, how can I represent objects in code? Like this doesn't make any sense. How like what is all these dunder methods, this init he brought up in Python, dunder init, like underscore main, like all these kind of all this stuff. Like I was like, what is all this stuff? Instance variables, decorators, getters and setters. I was like, this is just nuts. But then I just marinated it for a little bit. I just cooked it in my mind for about a week. And then I just thought about, okay, what is a class? Okay, it's just representing an object, real world objects. Well, I'm a real world object. Humans are a real world object. So if I wanted to write a program to represent just creating humans, like kind of like a machine, just that churns out humans, well, I could use an object-oriented class where I have a class called human with parameters that are associated with various physical characteristics of a human. Let's say they could be, emotional characteristics or intellectual character, any types of characteristics associated with that object you can describe with instance variables. So it's like, okay, well, I have brown hair, so let's make a class called hair color or an instance variable hair color. Well, Mike has, so I just got practice with that. And then I started building, and then what I did is I took stuff in my real world. So like I'm a chemist, right? And so I deal and have to check out like inventory via the chem store system. If you're familiar with like wet lab stuff, every lab has a chems stores or chemistry storage like unit basically where all their inventory is kind of mass kept. And so I created objects which were these inventory objects, something I was familiar with on a daily basis, and some attributes or instance variables associated with these class inventory objects or chemical objects was a part number, a lot number, like a quantity, a unit, right, for that quantity. And so I just got some actual practice with things I actually dealt with in my real world life to help kind of just boost that and solidify the topic, right? Yes, it's fun and it's great to learn about, recreating dogs and cats as objects and cars, right? That's the typical thing you do. You make a car object with a different color, or a house object with different colored doors and shingles and, bedrooms and whatnot. But in theory, those don't have any real world practice. And when I was always learning and in college, and when I was an undergraduate teaching fellow, teaching chemistry to the undergraduate students, and when I was a lab instructor, teaching the lab to the chemistry students, like running the lab, administering the experiments, I really tried my best to tie in some real world applications, because in my point of view as a student, if I didn't have any real world application, my immediate thought was, why am I learning this? This is a waste of my time. Like, if I'm not able to apply it into my everyday life in some way or another, I really didn't have a care. And so now I don't really feel that way anymore. I just like to learn just to learn. But for many other people, it might, seem that way. So if you're finding yourself like not really being super like, engaged in the learning, try to apply it to something you actually care about on some sort of level, whether it be and something you're actually more familiar with, right? Convert it to tailor to your, and use the AI to do that. I had a guy come in here I'm not sure if he's in here, but he kind of was joshing me because he said, "Oh, this guy's got the AI off on the other screen. He's just looking at it." Yeah, I had my AI off on the other screen, but not once in this AI here did it show me any code, right? I mean, yeah, it tried to, but I stopped it before it was able to. I gave it mine and I asked for like, guidance, right? I mean, there it gave me a one-liner, but I said, but whatnot, right? It was just a simple fix. But not, you don't see any code here, right? I'm using this AI as I would a TA, a teacher. And then you can also be creative. Like, this is why I'm so heavily invested in like these AI companies on like a market basis, because I've been able to perform and grow and learn at an exponential rate compared to where I was as a student actually in class every single day, all day. In the short 2 to 3 hours after my job, already making my 40 hours a week worth of money, I'm able to pretty much gain so far almost a sophomore to junior level computer science, um, sort of certain mediocre education here, and programming skills. So like, and that's for free. So it's really crazy. On what I said, you probably need to remove the first of the window. Check what valid it is to remove from the dict frequency counter and keep removing it until it's valid subarray. Yeah, exactly, Douglas. That's what we're doing here, man. That your suggestion is tying in. We're doing this loop because we're removing the left pointer frequency as we go. You have to continually check the left pointer, as you shift that valid window size that you've created downward until you're able to move the right pointer forward to increase the window, on finding a new section to parse, basically, right? You're starting at the same place, you're moving the right forward. Okay, we found a valid window size, we stopped there, we shift the window completely together until we find another valid chunk, and then we move the right forward again. So that's kind of how I'm viewing this. Hey, keep cool. This one was a little bit challenging. I pretty much got the algorithm, like not I didn't get the algorithm like in terms of performing it, but I knew what algorithm we needed to use, what but two algorithms we needed to use, or techniques. We needed to use a sliding window algorithm and a hash map, type of frequency counter here. So I got the data structure and the algorithm like right away within the first 5 minutes, but actually writing the sliding window I've never done before. I was able to recognize that this is a sliding window because I've been purposefully, stalling and procrastinating learning sliding windows. So we took a good hour and a half or so to actually learn sliding windows and research them. We looked up some stuff, we watched a video on them, and then we were able to solve this problem with some practice. But this one was a little bit challenging, but it was pretty obvious of what you needed to do. But setting up the window is a little bit hard, at least because I've never done it before. Thanks for coming in, dude. Hopefully that answers your question, Big Task. And so, what regarding the AI, what I did when I was learning a lot is I used it like I do now, but I would also ask it to create me things. Like, you know, he really is so crazy that we have this tool that can just generate you like practice problems out of nowhere. Like before, you had to go physically make flashcards on Quizlet or find someone else's flashcards. AI and ChatGPT is going to completely put Quizlet out of business. Like it's going to completely put like these, um, independent educational like tools out of business because they're going to be no longer they're no longer needed. You can just auto generate these cards basically for you on a certain surface level, right? Nothing too deep at the moment, but that's currently like what flashcards do, right? So I'm pretty much like I used it a lot like, hey, can you write me like three practice problems that go over these concepts for this kind of level? And then I would go and do them, and then I would go and work through them with it, and like just use it as your TA. That's like what I do. It's what I've done here. All right, you guys. I appreciate you guys being here and hanging out with me. We streamed for 2 hours and 25 minutes today. We were able to solve this medium leak code problem. Today, we only were able to get this one done. We did a lot of learning here. So how if I don't need another loop, then how would I continually do the check though, right? If I did the if statement, right, and then I moved forward, well, what's stopping that number from also being a a one or the number we stopped on, right? So you need to shift the rate. You need to loop innerly forward, right? I believe. I mean, let's see here. Do these always have loops? I mean, this has two nested loops, right? Um, I mean, let's go here. Let's look at some solutions here. Yeah. So now we're getting into the O of n squared stuff over here. Well, no, this is correct. It just uses this counter, which is slower, right? So all of these use that nested loop. All right, you guys, thanks so much for joining me today. I'll see you guys tomorrow, where I'm going to try to. I want to come up with another project. I think I want to get it. I've been wanting to maybe build my own like virtual guitar amp simulator, like some sort of like tube amp or something I can apply various like effects to, like distortion, reverb, all the delay, all these kinds of effects, and get into like maybe manipulating audio files. But I was doing some research before the stream regarding that, and it seems like a lot of these programs that do audio files with extreme latency, like low latency dependency, is written in C and C++ mainly, especially C++. So, I mean, we can definitely try it out in Python using AudioPy or whatever, PyAudio, um, and Wave. I was doing some research on those two libraries, but because they're built off of the audio libraries that are in C, right? Or in C++. So, but the thing is with Python is that the latency grows a lot higher. Like going from like a standard of like 64, what is it, milliseconds to like maybe 150 milliseconds. Like with Python, it's recommended to have like a latency of like 300 to 600 milliseconds. So, and having a latency that bad on like a live feed for like an amp or like a playback of audio, you know, is pretty rough. You know, it just is a lot of delay. So I'm trying to think maybe we have to might have to go down the C++ route for that and start to learn that. There's been a lot of people on the stream that have been waiting for me to learn that stuff. But also, I wanted to maybe try, maybe before we do that in Python, I wanted to build a kind of like a mass portfolio viewer. And what I mean by that is where you can basically, add various financial accounts to an overarching portfolio. And then within those various accounts, you can add additional trades and have journals and whatnot. So it sounds like something like object oriented that we could do pretty easily, and whip up in a few days. Honestly, it doesn't seem like it would be that hard. So I think I might take this weekend to try to build it, because I definitely want something like that for myself, where I can just load in basically all of my. Now, there are companies out there like Stripe and stuff that let you sync and log into your like Robinhood or Fidelity or Schwab or whatnot, and they can get that information like via API, right? So we could also have that take place. Yeah, it's interesting. Let me know what you guys think. What matters is the maximum size of the valid subarray. The sliding window isn't just to count it. Yeah. 2KU cast says there might be some Python audio libraries that interface at a lower level for better latency. Hey, CodeBam, how's it going, dude? Welcome in. We're just about to kind of sign off here for the night. We solved this Leet code problem. Maximum subarray length using sliding window and a hash, which is pretty good. But we're just talking about maybe the next project we want to do regarding potentially. So that I have two ideas. I have three ideas really. One is a virtual amp, like a virtual vintage tube guitar amp simulator, that would take in like a live feed via a plug-in here on my interface, and that could, or like audio recording, and could you could apply various effects like distortion, delay, reverb using like NumPy arrays and to manipulate the byte, the code basically, the waveforms. My second project idea is the overarching portfolio, like stock portfolio viewer, where you can just load in multiple accounts and then have an overarching view of your total like net worth of your kind of stocks altogether. And then my third idea is kind of the project pacer, where we talked about this before in the Wackathon idea, where you can like pace projects out and assign them various kind of tracking tags to have better analytics or metrics regarding your project timeline and like success rates and stuff, which would be pretty cool. So let me know what you guys think about that. But I'm going to head out here tonight, you guys. I'll see you guys tomorrow at 7 p.m. PST. My name is Michael. I have a degree in human biology and a minor in chemistry, where I work as a formulation chemist for a biotech company. I've been doing that for over 3 years now. We are starting to solve Leet code problems. I think this was our 83rd Leet code problem we solved. We are starting to dish out some applications. I have a screening for a chemistry software engineer position on Friday, which is pretty cool. So I'll let you guys know how that goes. It's just like a 15-minute screening, so hopefully, fingers crossed, it goes pretty well. Yeah, but we just started applying places. We got a hit pretty quick there, so that might be lucky maybe, at least for that. But a couple days ago we made the resume. Join my Discord if you want to see that. And yeah, thank you guys so much for being here. I'll see you tomorrow. Subscribe, and I'll see you guys tomorrow at 7 p.m. PST, where we learn and teach ourselves how to code every single day. Have a great night, guys. I'll see you later.